In section 9.5, we learned two rules of differentiation. One of them is the product rule. The other one is the quotient rule. So let's get started with one example, number 24 on 9.5. It says f of x is equal to x squared plus 1 divided by square root of x. This is a quotient, therefore we have to use a quotient rule. But before I do that, let me modify this and get rid of the square root sign here. So I rewrite this as x squared plus 1 divided by x to the 1/2. Write it as an exponent. Now, the quotient rule says that if you have a function like this, which is in the quotient form, the way you find f prime of x is equal to, first, derivative of the numerator, which is 2x, multiplied by the denominator, which is multiplied by h to the 1/2, minus derivative of the denominator, which would be 1/2 h to the minus 1/2 times the numerator, times h squared plus 1, divided by the denominator, h to the 1/2 squared. One more time. Derivative of the numerator times the denominator minus derivative of the denominator times the numerator divided by the denominator squared. That's what I have here. I'm going to multiply everything and make this simpler form. F prime of x, therefore, is equal to 2x times h to the 1/2 would be equal to 2x, add up the power, that is 1 plus 1/2 is 3/2, minus 1/2 h to the minus 1/2 times h to the 2 would be minus h to the 3/2, minus 1/2 times h to the minus 1/2 divided by h to the 1/2 squared. You multiply the power, so this would be x. Therefore, f prime of x is equal to, I have 2x to the 3/2 and minus 1h to the 3/2. That would give me only 1h to the 3/2 minus 1/2 h to the minus 1/2 divided by x. I probably can simplify this further, but I think this is basically enough. Well, let's just take one more step. F prime of x equal to, I can separate this as h to the 3/2 divided by x minus 1/2 h to the minus 1/2 divided by x. From chapter 1, f prime of x, we know this would be equal to h to the 1/2, and here would be minus 1/2 divided by h to the 3/2, therefore equal to h to the 1/2 minus 1 divided by 2h to the 3/2. That might be good enough. If I want, I can take the common denominator and bring it back one more step. Let me do it one more step. You never know when to stop. So denominator would be 2h to the 3/2. Then denominator of 1. 2h to the 3/2 times h to the 1/2 would be 2x squared minus 1. Well, maybe this looks better than everything else. This is the derivative of that function. That was problem number 24. Next, problem number 42. Number 42, it says find the slope and equation of the tangent line to the graph of the function f at this specific point. Again, the slope of the tangent line first is the derivative of the function at that x value, which in this case is equal to 4. So if you have f of x, which is equal to 1 plus 2x to 1/2 divided by 1 plus x to 3/2, first you have to find f prime of x and then evaluate it at the point of x equal 4. Okay, so again, based on the formula, it says derivative of the numerator times the denominator. Derivative of the numerator in this case is x 1/2 times 2 is 1 h to the 1, subtract 1 from the power, it would be h to the minus 1/2 times the denominator, which is 1 plus h to the 3/2 minus derivative of the denominator, which is 3/2 h to the 1/2 times the numerator, which is 1 plus 2x to the 1/2 divided by 1 plus h to the 3/2 squared. That's just based on the following the rule. Therefore, f prime of x equal to h to the minus 1/2 plus 3/2 and 1/2, it would be only 1, so it would be plus h to 1 minus 3/2 h to 1 minus 3/2 h to the 1/2, and minus 3/2 times 2 is 3 minus 3 h to 1 divided by 1 plus h to the 3/2 divided by 2. Let's do something to simplify this a little bit. F prime of x therefore is equal to, well, h to the 1/2 is basically h to minus 1/2 is 1 over square root of x. Now here I have plus x and minus 3x would give me minus 2x. And here I have minus 3/2 times h to the 1/2 power, that would be square root of x divided by 1 plus h to the 3/2 is square root of x to the 3rd, the whole thing squared. Now, if I want to find the slope at the specific specific place, which means at x equal to 4, remember we wanted for 4 and 5/9. If I wanted at x equal to 4, all I have to do is to evaluate this f prime, this function, at x of 4. So every place I have x, I put in 4. So it would be equal to 1 divided by square root of 4 minus 2 times 4 minus 3/2 square root of 4, 1 plus square root of 4 to the third, the whole thing to the second. So f prime of 4 is equal to 1 over square root of 4 is 1/2 minus 8 minus 3/2 times 2. And here in the denominator, I would have 1. Square root of 4/3 is equal to 2 to the third, which is 8 to the second power. Therefore, here I would have 9 to the second power. And in the numerator, I would have 1/2 minus 8 minus 3. That's minus 11, and plus 1/2. So f prime of 4 would be equal to minus 11 plus 1/2 is equal to minus 21/2 divided by 9 squared is 81 equal to, once you simplify this, this would end up minus 7 divided by 54. This is the slope. Again, the formula says it is y minus y1 equal to m times x minus x1. So here would be y minus, y1 is given in the problem number 42 as 5/9 equal to slope, which is minus 7 divided by 54, times x minus, x1 is given again as 4. So y minus 5/9 equal minus 7/54 x plus 28/54. When you simplify this, y would be equal to minus 7/54x plus 29/27 after you simplify it. This is the equation of tangent to the function at point 4 and 5/9. Problem number 46 is talking about second derivative, which is basically simple. It's a find the first and the second derivative of the given function. So the function is shown as the g of x. Again, you can call it f of x, g of x, h of x, whatever, it doesn't make any difference, equal to minus 3x to the third plus 24x squared plus 6x minus 64. The first derivative, g prime of x, would be equal to minus 9x to the second plus 48x plus 6. The second derivative, which is the derivative of the first derivative, you show it as g double prime of x. It would be equal to minus 18x plus 48. That's it. That's the second derivative. One more problem I like to do an application problem here, and that is problem number 60. Problem number 60. Cost of removing toxic waste. A city's main well was recently found to be contaminated with some toxic material, a cancer-causing chemical. As a result of an abandoned chemical dump, leaching chemicals into the water. The proposal submitted to the city's council members indicates that the cost measured in millions of dollars of removing X% of the toxic pollutant is given by this function. Again, this is number 60. Same section 9.5. The cost of removing toxic waste in this place, C of X, is equal to 0.5X divided by 100 minus X. Find C prime of 80, C prime of 90, C prime of 95, and C prime of 99. What does the result tells you about the removing all the pollutants? Okay, C prime of 80 means 80% removal. What is the additional cost for 80%? Additional cost for 90% removal, 95% and 99%. So first we have to find C prime of X. Again, using the quotient formula. Means derivative of the numerator, which in this case is simply 0.5, times the denominator, 100 minus X, minus derivative of the denominator, which happened to be minus 1, times the numerator, which is 0.5X, divided by the denominator, 100 minus X, squared. This is just following the formula, the rule for differentiating quotient. So C prime of X, just simplify this, equal to 0.5 times 100 is 50, minus 0.5 X plus 0.5 X divided by 100 minus X squared. Now, minus 0.5X plus 0.5X would cancel. Therefore, C prime of X is equal to 50 divided by 100 minus X squared. This is the derivative of the function. Now, if we want to find C prime, of 80, that means 50 divided by 100 minus 80 squared. That is 50 divided by 20 squared, which is 50 divided by 400. Therefore, C prime of 80 here would be equal to 0.125 million dollars. Okay? So the rate of change in cost of moving 80% of the toxic waste is 0.125, which is $125,000. Removing 90% would be equal to 50 divided by 100 minus 90 squared, which is equal to 50 divided by 10 squared, which is equal to 50 divided by 100, which is equal to 0.5 million dollars. Okay? So the rate of change of the cost of removing 90% is $500,000. If you want to remove 99%, then it would be 50 divided by 100 minus 99 squared, which is 50 divided by 1 squared, which is 1. That would be equal to $50 million. Okay? That's the rate of change in the cost if you want to remove 99% of the toxic waste. What happened? You can see as X is increasing, this amount, this dollar amount is going up exponentially, basically. So if C prime of you want all 100% removed, then you would have 50 divided by 100 minus 100 squared equal to 50 divided by 100 minus 100 is 0. 0 squared is 0. So you have 50 divided by 0, it is infinity. So you need an infinite amount of cost. Infinite amount of cost to have going from 99% to clean to 100%. In other words, it costs you only, if you will, only $50 million to clean the toxic pollutant to the rate of 99% clean, to 99% clean, right? That's what 99 means. But if you want to go from 99% clean to 100% clean, the extra cost would be from 50 to infinity. To infinity. So basically, we say, or this formula would suggest, there is no way, no matter how much you spend, there is no way you can get the water 100% clean or 100% pure. Well, I hope these exercises we did at the end of each one of these sections is going to help you. Again, remember all the tools you have available to you. Number one, you have the textbook. Inside the textbook, you have examples in each sections that would make it easier for you to understand the material that is covered in each section. Number two, at the end of each section, you have what is called self-check exercises, and these self-check exercises is you have a complete answer to it at the end of the chapter. Number three, you have a CD which is provided by the publisher. That is an interactive CD, which goes step by step again over the examples in each section. Number four, you have the original DVD lectures, which is over the material that need to be covered in this course. And finally, well, number five, you have these extra additional exercises we are doing here from each section. And finally, you have the complete answers to all the odd problems at the end of each section. So you have a whole lot of material available to you to get you ready for the course. Sometimes it may take less time for you to understand, sometimes more. And plus, like I said, I had those two sites, internet sites, like algebra.com. Algebra.com is a good site, and it has an interactive, it has a video, not an interactive one, but it has a video where it will teach you some of the basic concepts. I wish you well, and that's the end.